Good afternoon, everyone. And as I discussed, um, I will not be there to Zoom with you live um, today. That is the Friday. And Mr. Kenton will be your sub, and he will be taking care of your assignment. And any questions, feel those who are in the class or those in the Zoom, feel free to chat or ask question. If you have any more questions, feel free to email me. So let's see what we are going to do today. Let me share the screen. And let's go to the warm-ups. So we have discussed about the evolution and the natural selection. And I'm asking you here, how does the environment affect the evolution of species? So I'm giving you a giraffe here, and you can see the long neck. Then this frog is on the whitish brown surface. And this is the cactus that has the thick um, succulent leaves and the stem, and is in the desert environment. So how does the environment affect the evolution of the species? Think about it and let me know. Feel free to chat, guys, call out. So basically here, what are we looking at? The environment of the giraffe changed. Um, the trees, the shrubs were gone and there were tall trees. So the giraffe had to evolve according to that environment and develop long necks. Now these frogs, to survive, they evolved and they come to camouflage with the surface, the bark of the tree. They had to survive from their predators. They also changed the color of the skin, like the peppered moths, how they changed after the industrial revolution, when the bark of the trees became um, black, then these peppered moths also mutated, and the offspring that were there, they had black color to camouflage with the trees of the bark of the trees. Now, this cactus has also, the environment has affected the evolution because the environment has limited water. So they evolved, the cactus evolved, developing thick succulent leaves at the stem to retain water. So the environment does affect the evolution of the species, and you can see that example in the giraffe, in the frog, and in the cactus. So today, after the warm-up, we've already discussed, we'll be doing, um, actually the notes have already been done. So you've already done the notes. And if you still want to go back to the notes, then you will be having that. Then you will be working on anatomical um, homologous, homologous, and homologous assignment, which is a practice prep 10 points. And exit ticket, those who have not done, please complete. Complete and submit. So main thing is that today you will be working on the assignment on the anatomical and homologous and the analogous assignment. And it's go back to your notes. If you want to refer to anything, they're already in your day one in this module. And please feel free to refer that. I've also added my recording of the previous lesson, which you can access for 3 days. And please, standard rule, those who have not completed their assignment, any missing assignment, please submit that. check your grades, check your emails, go to your assignment tab, see which assignment has a 0 or no grade, and submit. And I've always been like contacting you through emails. So let's look at what this assignment looks like. So go to your module, and the warm-ups I've already done. They're here. And MP4, week 6, anatomical evidence of evolution. So this is the assignment I'm talking about. So when you click on this, you can load it in a new window. It is a Cami doc. Because there'll be some coloring, so you can easily choose your colors and pick a pen. It'll be easier for you to. So this is the assignment that is due. So let's talk about it, what to do. Okay, let's go to the browsers. Start from the very beginning. So this is the assignment we're going to work on, anatomical evidence of the evolution. So last class we learned about what is homologous and what is analogous structures. So if we study the anatomy of the development of animals, we can see that many living creatures, they look quite different on the surface, but they have some on many similarities underneath the skin. These similarities, they tell us that these organisms were related to each other. There is evidence that living organisms have evolved or gradually changed over time, but there has been a similarity. So in this activity, you're going to learn about the homologous, analogous, and vestigial structures and their value as evidence for evolution. So let's talk about the homologous structures first. Now, what are homologous structures? We described them last class. They are basically same basic plan, same kind of structure, but different functions. Like homologous, homo means the same, and logos means the information. So same information. And they tell you that they had some relatively recent common ancestor. So the roots were the same. So you will be examining the drawing of the four-limb skeleton in the figure 1 on the last page of this assignment that you've been given. And you will be looking for the similarities in the bones amongst the various animals. You'll be coloring the human arm first. Color each bone a different color. They have been lightly shaded with a different pattern to help you identify which bone is that. And then once you're done, then color the corresponding bones in each of the other animals with the same color as the human bones. So start with the human arm and then color all the other animals. So let's look at that assignment where it is. So if you scroll down in this in your assignment, you have this page, which is the comparative anatomy page. This is the page I'm talking about, where you're going to color the human arm and the corresponding bones for the whale, the crocodile, the cat, the bird, and the bat. So as you can see, these guys have a pattern, each bone, so to identify that which bone are they referring to, because the size and the shapes are different. So let's get back and I'll color with you so that you also can color along with me. I'm here now. This is it. And you don't have to be perfect in the coloring. You guys can just draw the line just to identify which bone you're coloring and choose 6 different colors of your choice, but you don't have to be perfect. So let's start with the humerus. And I'm choosing maybe like a blue color for humerus. So here we go. Blue color for, no, hold on. Why is this not blue? Choosing a blue color for humerus. So this is the humerus bone. I'm going to color this guy. Doesn't have to be perfect, like I said. So this is the humerus here, and this is the humerus bone here. Color this. You can outline and fill it up. You don't have to be perfect. This is the humerus here. And this is the humerus here for this guy. And this is the humerus for the bat. Then for the ulna, you choose only for the human arm, they've been labeled. So you can choose a color for ulna. And this is the ulna. So choose the color for the ulna here. This is the ulna here. This is the ulna. There has been a pattern that you can help you to locate. This is the ulna. And this is the ulna here. And I think this is the ulna here. One of them. Then do the radius bone. I'm going to choose a purple color for this guy. Again, you don't have to be perfect. Choose all the different colors and just do a line so that you know actually what, where and which structure you are referring to. So choose this color, and there's a pattern for you to identify where are these bones located. Okay. Then is the carpals. These little guys are the carpals. That is basically your wrist. So I will choose the red color. These are your carpals here. Right? These are your carpals here. These are your carpals here. These little guys. These are your carpals here. Carpals here. Carpals. Then there are the metacarpals. The metacarpals are here. These are your, basically this is your hand. These are your metacarpals. These guys are your metacarpals. These are your metacarpals. Color these guys. Off here, but you're just getting the point. And my last one are the phalanges. Those are your fingers. Which color haven't we used? Let's use a school color, orange. So these are your phalanges. These are your fingers. The tips, here, the bones. Now, once you complete this, the coloring, it's a very good activity. Coloring, like basically, it some people love coloring. It is a very relaxing activity. Now, once you're done with the coloring, you are, if you want a better view for you're comparing human, whale, crocodile, cat, bird, and a bat, and choose the colors for human arm. They have a design, and then go and color the whale, crocodile, cat, bird, and the bat. So once you're done with that, then you will be answering the questions. So these are the questions that you're going to answer. Observe the each skeleton again and describe the function of each limb in the table below. So answer these questions. What is the function of the human arm? What is the function of the whale arm or a wing? What is the function of the crocodile leg? What cat leg, bird wing, and the bat wing? So I think you already know those. They're not very complicated. Human arm or the limbs are used to hold and grab things. They're used to walk. Whales have been used to for the swimming, the fin. The crocodiles, they crawl on the marshy lands. The cats, they walk, they can hold, and they can scratch, of course. They love scratching. The birds, they fly, and the bats also fly. And they also use um, uh, their, uh, their arms to cling to the branch. So we recorded the functions. After you're done with the functions, then you answer the summary questions 1 through 4. So skip this part right now because we'll come back to the homologous structures. You will be answering the questions 1 through 4 of the homologous structures. So 1, 2, 3, 4, they are here. Let's look at these guys here. Now, are the functions of the limbs of each animal the same or the different? Explain, providing an example. You're looking at the function of the limbs of each animal. So is the function that you just colored, is it same or is it different? You just answer these questions. So the functions you saw, they are different, and they are different. And you can quote the example, like for human arm is used to hold grab things, while bird's arm is used to fly or to cling to the branch, or cat is used for to hold the things or to walk, and the whale is being used to swim. So answer that. Then, and please make sure you provide the examples. Then are the bones of the limbs arranged in a similar or a very different way in each animal? Explain, providing example. The basic plan of the bones are the same. So they have those all those characteristics, like you saw the human arm, you saw these bones. They have the humerus, they have the ulna, the radius, they have the carpals, they have the metacarpals, they have the phalanges. All of them, human, whale, crocodile, bat, bird, cat, all of them have. But their basic plan is the same, but the size and the shape varies. For example, like look at this guy. For the whale, the ulna and the radius is so small as compared to the human or the cat or the bird or even the bat. So the whale has the very small ulna and the radius followed by the crocodile. So their basic plan is the same, but the size and the shape vary. Does the similarity in the bone structure suggest a common ancestor among these animals? Use a direct textual evidence from the background reading to support your answer. Yes, and that's what it is. They have the same structure, basic plan, but different function that actually tells you that they have a common ancestor. And you can go back to your notes also and see that they were all the limbs that I showed that the common ancestor was the fish. So because the same structure, but probably they evolved over a period of time to adapt to the environment. Like I showed you the picture of the elephant, the whale, and the hippo. They had the same basic structure of, they had teeth. So they had the basic plan, but the teeth of the whale, they evolved based on their environment to survive in the water and feed in the water food. Offer a possible explanation for how the skeletons can be similar, but the functions are different in each of these animals. So basic plan is the same. They're the same bones, but different shapes and the sizes, but the functions are different in these animals. Like going back to this guy, the human, whale, crocodile, cat, bird, and the bat, they had the same basic plan of the bones, but different functions. Like you can clearly see whales have been used for swimming, but the human for walking. So these structures are homologous, which tells you that they are basic plan is the same, structure is the same, function is different, and it also tells you that they have a common ancestor which evolved slightly to make changes to the environment um, adapt to the environment. Now you go back to, after doing this homologous activity, now you will be doing the activity B of the analogous structures. These are also, there are also many examples of the body structure in the animals that are very similar in function, but different in structure. As going back to your notes, we studied about the analogous structures. So they have a different structure, but same function because they probably were in the same environment. And these structures are called the analogous structures. Analogous structures suggest that the structures developed independently of one another due to the similarity in the environment, but the two organisms do not share a recent common ancestor. So as compared to the homologous, these guys have a different structure, but the same function, and they do not have a common ancestor. So now we are going to examine the butterfly wing and the bird wing shown in the figure and look for any similar structures and answer the questions 5 through 7. So first we will look at the butterfly wing and the bird wing, and let's see what is common and what is different in there. So examine the butterfly wing and look at this. So look for the similar bone structures. Do you think that the butterfly wing and the bird wing have the same structures? Bone structure, the bird has a bone, but the butterfly does not. I don't see that. So no, they do not have a common structure. But what do you think? These birds have a bone, but the butterfly does not. But the function is the same. Both the wings of the butterfly and the bird wing has been used for flying. So write that down, that they do not have a common structure. The bird has the bone. None of the structures are common. The butterfly has the no bones. They have membranes, uh, thin membranes, and the bird has the bone. Now, after you're done with this, now you're going to answer the questions 5 through 7 of the analogous structures here. 1 through 4 have been answered, and now you're going to answer 5 through 7. So let's look at that. What function do the butterfly and the bird wing share? The function is the flying. Both the butterfly and the birds, they use their wings to fly. And in what way do these structure differ? They differ in the structure, like if you go back and you see that the bird wing has a bone, but the butterfly wing does not have a bone. They have maybe thin, very thin bones covered by the membranes. So that's why the reason the structures are different, but the function is the same. Explain why these are considered analogous structures and not homologous. Homologous structures are the ones which have the same structure but different functions. But the bird and the butterfly, they have different structures in the wing, but the same function of the flying. So they are analogous structures, and they do not have analogous structures, do not have a common ancestor. So bird and the butterfly, they do not have a common ancestor like the forelimbs of the mammals that you did. Different structure and same function. After you're done with this activity, please submit this assignment. And then I have given you the link on in your module. Let's go to the module. Module is here. I will be posting a link here next to the day 2 for your vestigial organs. So please watch that video of the vestigial organs and submit your the assignment of homologous and analogous structures. Again, the same common thing, please check for your emails, check for your grades, check for your assignment tab, go to your assignment tab, and anything that has a grade 0 or no grade, please submit. Any questions or comments, please feel free to email me and let me know how I can help you. I will stop the share now, and thank you guys. I will be with you next Tuesday. And thank you, Mr. Kenton, for taking care of my class today. Bye-bye, guys.